I'm Richard Thomas from Western Sydney University. I work in the School of Science. We have a rapidly expanding berry market in Australia, but there is a building up issue of the oversupply of nutrients, and what we're trying to do in this project is show the growers that they can get the same outcome with less nutrients without any loss of productivity. So what we've been doing is trying out different types of nutrient solutions on the blueberries and then working out what the issue is. And we've come across a couple. One, the problem is that they can't get the nutrient to stay in the pot long enough, so they oversupply the nutrients. And the second one in winter is when they cut down the amount of water they're putting on, that will send the salinity of the soil skyrocketing up to high levels. We're building together a program for the study of nutrient. We've got growers involved, we've got suppliers of blueberries, because we want to know which varieties would be best, which varieties avoid this problem, if any, what's the best nutrient to be putting on. There are questions about blueberry nutrients. That's one major topic of research we're doing, is to look at the nutrients, but also to find out how it's going into the plant and what form is the best to deliver it as. Do we deliver it as ammonium? Do we deliver it as nitrate? Or do we deliver it as urea and let the plant convert it into ammonium? Can we retain those nutrients in the pot long enough to make a difference at the lower concentrations than currently being used? We've got a group of master's students who are doing master's projects as part of this study. We've got PhD about to start, and we've got another master's student coming to do an MRes with us. With all research questions, as soon as you open the lid on it, we end up expanding and expanding and expanding, especially if you're looking down at the level of chemistry. There's a whole heap of unanswered questions that then become open. We can see what the problems are. Now the thing is, we want to look at things like, does biochar hold the nutrient in the right way? Are we right to use a Hoya base, which is what everybody does, because of its high cation exchange capacity, or are we inviting in the problem of potassium buildup in the pots that we're seeing? We're confident that we can produce a system to show growers they can get the same outcome, cheaper. There is, we believe, no reason. If they choose the right delivery system and we can show them the right nutrient, they'll get the same outcome. We're confident we can get that result there. The next step is to get the larger trial underway. What we're keen to do here is work on as many different growing systems as possible. So here we're in a polytunnel, but we have tables set up outside. We'll look at the outdoor environment, but we'll also look at the shade cloth. What we're aiming to do is to keep the technology as simple as possible, to be more realistic, so that the outcomes are translatable directly into industry. So we're going to look at the shade cloths up there. We've got a medium tech greenhouse up the top that we're going to fill, and we've got this tunnel here, and we'll produce an outcome that then anybody can see, that's the system I've got. We're using industry best practice in terms of nutrient supply, so the research will be translatable directly into practice in the industry. I'd love to collaborate with more different nutrient suppliers. If there are other nutrient suppliers out there who are wanting to test their product against the others in a realistic situation and work out whether their product is better than the currently available, then we'd be happy to collaborate with them as well. And we're interested in anybody growing new varieties. If they want to trial them out here, we'll try them out here. And we're interested in the outcomes of this research.